questions then. Okay, so one of my questions I asked you was, how is the nervous system? Okay, first of all, what is the nervous system? Yeah, how the body communicates, right? And what else? Not just communicate, but what else does it do? Remember, we kind of good through the last week. Communicate and control, right? So last week we talked about controlling by hormones. You guys remember? What do you guys think? Is that pretty fast or pretty slow? Slow, because you gotta take the hormones in the blood, you gotta go around the bloodstream, right? Today is the same type of communication and control, but it's a lot faster. Yeah, a lot faster because it's nerve conduction. Okay, so I asked you guys, how is the nervous system organized, right? It can be organized either structurally or functionally. Structurally, think anatomy, think location. So what's the answer? It can be organized structurally by anatomy, so it becomes what and what? Central and peripheral. Good. Yeah, so CNS versus PNS, right? So CNS versus PNS. So what is central? Brain and spinal cord. Good. Okay. So PNS. What is PNS then? Everything else. Okay, everything else. Okay. So I want to generate a list of comparing PNS versus CNS. Okay. So I'll say red for something special. So I'll use black. Okay, so we talk about CNS as being brain and spinal cord, and PNS is everything outside the CNS. We can also talk about functionally. Okay, what does that mean? Dividing the nervous system, not structurally anymore. Okay, so this is not anatomy. What do we mean when we say function? The role in place, you're on the right track. You keep going. Okay, so this is the structural, right? The structural. Okay, so I'm just gonna back up. So CNS is just brain and spinal cord, right? And then everything else outside would be peripheral. So notice, in peripheral, what kind of word do you see? Nerves, right? So that I want you to remember. Students often get confused. PNS are nerves. So when you see the word nerve, it's automatically PNS. Okay? I don't care what goes before it. Cranial nerves, you say, oh, cranial brain is CNS. No. After the word nerve is going to be PNS. Okay? And what else? What else? In the PNS, we have something called ganglia. Okay? So I'm going to put that up here as well. So now, what is a ganglia? Anyone know what a ganglia is? Cluster of? Not just neurons, but this is part of a neuron. Cell body, yes. So ganglia is cluster of cell body of neurons. Okay, so wherever you see cluster of cell body, okay, so I introduced cell bodies in lab, yes? What the heck is a cell body? Hold on, I need some hand volunteer. I'm waiting for 5 hands to volunteer here. We just had this like less than an hour ago. And, okay, so I have 2 hands, 3 hands. Yeah, a couple more hands. Hey, I'm gonna pick at someone who didn't raise their hand because that's what you get for not raising your hand. All right, so Durga, what's a cell body? You can look at your notes. Okay, so everyone look at your notes. Okay, what is a cell body? What is a cell body? I mean, I don't know how else I can get more general than that. I mean, just anything. Throw me a vocabulary that applies to cell body. What is a cell body?
Part of neuron of the nucleus.
Good. That's fine. Part of a neuron that has a nucleus, right? Okay, so we just looked at a neuron last hour, correct? So that part of a neuron that has the nucleus, that's called a cell body. Okay, here's a harder question. What's another word for cell body that I might use on the test? Soma, exactly. And you need to understand it's the same thing, okay? So when we have neurons, and you see a cluster of cell bodies of the neuron, and it's in the peripheral nervous system, we're going to call it ganglia, okay? So you're going to see this word a lot, so I want to introduce it now. I'm going to erase this. I'll put it in. Okay. In the CNS, we use a different name, and I don't know why, but it just is. So in the CNS, a cluster of cell bodies means we're going to refer to as nucleus. You're like, what? Yeah. So up to now, you know nucleus is that structure inside a cell with DNA, right? Easy to see on the histology slide because it's usually kind of dark purple. From now, for this chapter and next chapter, when you see the word nucleus, it has a different meaning. It means cluster of cell bodies of neurons in the CNS. Okay, CNS. So just be careful of that terminology. In both situations, these either nucleus or ganglia is going to be gray matter. Okay. Well, actually, I don't want to call it gray matter here. Okay, so in the CNS, you're going to hear, you heard people calling white matter and gray matter, yes? Okay, I'm just going to introduce it now. Gray matter is going to be the nucleus. Okay. What else do we call it with a CNS? So nucleus, you can also call it horn. Like what? Yeah, pretty bizarre name. We'll go here. I'm just brief overview right now. It can also be called horn. Okay. All right. So anyway, ganglia, cluster cell body, and there's usually this little bump in the peripheral nervous system. By the way, the singular is ganglion. If it's singular. Plural. Okay, it's gonna be ganglia. Okay, let's move. Okay, so let's go to functional now. So we look at CNS versus PNS as a anatomy word. How else? How else can we divide the nervous system functionally? Yeah. Okay. But so sensory versus motor. Okay, sensory versus motor. Now, sensory is also input. Okay? Another way of looking at sensory is inputting information to the CNS. And motor is going to be output. So we learned words like last week and the week before, something coming into the glomerulus. You guys remember? What is that called? Coming into the glomerulus last week? Afferent. Arteriole, right? And leaving the glomerulus was efferent. Look at this again. They call motor efferent because it's coming where? It's coming out of the CNS. So sensory can also be called afferent. Okay. So what do you think? Is it CNS or is it PNS? Afferent and efferent. Is it in the brain and spinal cord or is it outside the brain and spinal cord? Outside. So when we say afferent and efferent, it's PNS. Okay. Okay, so when we say motor, or we say sensory, okay, let's pick up sensory first, because most of you can understand. Give me an example of a sensory. What do we mean, sensory information? Okay, I'm going to wait for a few more hands, because I want to. Okay, good, you guys are getting the hang of it now. Because I'm going to pick on people who didn't raise their hand. All right, Alina. When I say sensory, what conjure up? Give me a vocabulary that would match with sensory. An example of sensory. Touch, right? Touch would be a sensory related word. Okay, someone else. Heat. When I say sensory, she says touch. Give me another example. Taste. Okay. So you guys get the hang of it, right? So all of this is sending information to the brain. Does that make sense? That's why it's afferent. Now, let's say you go with Alina, where I'm touching this thing and it's cold. So what do we tend to do? We tend to pull back, right? What does it take for me to pull back? It's a reaction involving what? Involving movement, right? Movement is caused by what? Muscle. Agree? So motor, think muscle. M for motor, M for muscle. M for muscle. It's going to involve movement. It's going to involve muscle. Oh, there you go, another M word. Muscle, movement. Okay, so sensory gives your brain information or get your spinal cord information, but then to respond, you're going to need muscle movement, and that's motor. Yeah.
You get goosebumps. Does that have to do with muscle?
Do you get what?
Goosebumps?
Yes, because I'm going to go there next. With your finger, okay, let's see you guys remember. Everyone get a vote. Give me a hint. No more than 5. How many different types of muscle do we have in the body? Let's review. Everyone vote. How many different kinds of muscle do we have in the body? All right. Most of you answered correctly. 3, right? So let's rattle them off. What are they? They are skeletal, smooth, and cardiac.
Oh, yeah. That's a good question.
Okay, so skeletal, smooth, and cardiac. So that's going to be the muscle that's going to be involved. Okay. Your heart can beat faster or slower. Agree? Your muscle in your arm, your limbs, your body, skeletal muscle can contract or smooth. Give me an example, or give me a location where we have smooth muscles. Small intestine. In the case of small intestine, it can contract, and what happens? It results in the content being moved along, right? What is that word called? It's a vocabulary. Peristalsis. Very good. could result in peristalsis. Agree? How about last chapter? Last chapter we talked about other system that has smooth muscle. Give me an example. Urinary system. Yes, urinary system. Give me an organ in the urinary system that has smooth muscle. Bladder. Yes, urinary bladder. So what happened in the urinary bladder when the smooth muscle contracts? You pee, right? You pee. That is a response of an efferent motor, right? I mean, we talk about this. We, as we grow up, we know when to pee and when not to pee, correct? So when you want to pee, it's because the efferent motor is telling your smooth muscle to contract to pee. Now, how do you know it's time to pee? Your brain tells you it's time to pee. What tells the brain it's time to pee? Your bladder is full, right? That's sensory. When your bladder is stretched, the sensory neuron is then sends a message to the brain saying, hey, the bladder is going to be pretty full, right? It's going to explode if you don't empty it. Does that make sense? So the full bladder sends a message to the brain. That's sensory. The brain says, oh, it means it's time to pee. And it sends a message to the motor, the efferent, to contract the skeletal, the smooth muscle, so you would pee. You guys understand the loop? Ah, another loop. You know, I love loops, right? I love pathway. And it continues. Okay. All right. So let's look at this. Give you a minute. All right. Talk to your neighbor. Talk to your neighbor. And I want you to discuss how else do we further categorize sensory and motor. Okay? So talk to your neighbor. How else do we further categorize sensory and motor?
It's inside, outside. Your choice, not your choice.
So somatic is
Somatic, like, you just feel everything. And then I assume visceral's like stomach's cramping. You get stomach pains.
so it's pain.
So that'd be like visceral.
So is that like pain?
It's more about where you're feeling things.
I was like, didn't we do this in psych?
Huh?
I was like, didn't we do this in psych?
And then voluntary.
I was like, where did I see them for? Where did I look for?
Why don't you turn around and talk to Jake?
It's like you just read the same word over and over again.
I feel cold. Tissue.
Need tissue?
I feel like I'm or something. Do you have that? Damn, thank you.
Okay, so
Asian.
hopefully you guys understand this chart. Yes? Any questions? Alright, because this is how I would ask you a test question, okay?
Can we hold tissue?
1, 2, 3, or 4. You guys understand? So use your fingers. We're gonna vote. I just gave you an example of the bladder being stretched. Correct? Is that an example of 1, 2, 3, or 4? Hold up your finger. 1, 2, 3, or 4. Bladder being stretched. That's it. Just bladder being stretched. That's all I'm. Okay. Bladder, urinary bladder is full, stretched. Is that an example of 1, 2, 3, or 4? Oh man, you guys are all over the board. This is what I worry about because you're looking at it but you're not understanding. First of all, bladder being stretched, is that sensory or motor? Sensory, right? So forget 3 or 4. Okay, but right off the bat, forget 3 or 4. So now you have to figure out, there's this thing called somatic sensory versus visceral sensory. Somatic means you get it from the skin, your joints, your skeletal muscle, special sensitive, which I have to admit you don't know what that is right now. But visceral sensory, receive sensory information from viscera. Now you saw this word before, right? Visceral, around the lungs, right? Visceral layer of the pleura, right? Visceral pericardium, agree? And so what was visceral then? Inner layer, but it was internal organs, agree? So viscera is internal organs. Viscera is internal organs. So now you narrowed it down to either 1 or 2, correct? So what? Let's revote. Give me 1 or 2. Good. It's 2, right? Bladder being stretched, an example of 2. Agree? Okay. Then I told you, so here it is, right? Bladder being stretched, the information is sent this way. Agree? Which means is afferent. Agree? Cool. That's in agreement with what we already know. Then I told you the brain is going to say, what? The brain's going to say, okay, the bladder is stretched. We're going to respond by peeing, right? So the brain decides you need to pee, but for you to pee, it's going to have to go down this way. Agree? And so I told you, or you already know, how we're going to respond. The bladder is going to contract. Agree? So the bladder contracting. Is that example 1, 2, 3, or 4? Hold on your finger. Everyone hands up. Hey, good. It's going to be smooth muscle. Agree? So that'd be 4. Okay? And so that's exactly what happened. The brain gonna send the message down to autonomic, okay, keyword here, autonomic. And it's going to stimulate smooth muscle to contract. Okay, smooth muscle to contract. So we're gonna spend a whole chapter here. It's a lot of stuff. Okay? So one whole chapter next week on autonomic nervous system. We're going to spend a whole chapter on special senses next week. Okay? And then, of course, the brain is going to be a whole chapter by itself. Okay? So nervous system is big, is huge. If you go on to more, higher level of training, like whatever, pharmacy school, dental school, nursing school, medical school. You actually have a whole semester on the nervous system, a whole semester. So here I'm watering it down to you guys for 2 weeks, and you may seem like, oh, it's a lot of stuff. There are way more stuff, okay? It's fascinating, okay? A whole lot of stuff. Okay? But do you have a better understanding now of how to deal with this table here? You guys understand? Stuff coming in, brain interprets, and then respond. So, all right, I need you to discuss with your neighbor, what does somatic means? What is somatic?
What do you want to do?
Yeah, so like you wanna kick a ball or something, you actually move your body.
This is somatic.
What about the external urethral sphincter?
What about what?
The external urethral sphincter?
Oh, yeah, yeah.
So I was kind of
The
confused on that.
sphincter
Is that, is like,
Yeah,
that's not smooth.
the external, right, the external sphincter is skeletal muscle. But I told you about the bladder, right? The bladder is smooth muscle. Yeah. Hey, so, I need a volunteer to define somatic. What is somatic? It's on this table twice. I have one volunteer, I'm waiting for a few more. Three, four, okay, all right. Once again, gonna pick on someone who didn't raise your hand. Jacob, what is somatic? Okay, somatic gonna involve skeletal muscle, right? Skeletal muscle, all right. Anyone wanna add on to that, other than skeletal muscle? Uh-huh, yeah, Valerie,
Voluntary?
is what?
Voluntary?
Voluntary, yes. So that's how I usually remember. Voluntary are stuff that you're consciously aware of. Agree? Because you voluntarily do it. You know you're doing it. So for me, I usually think of somatic as voluntary, I'm consciously aware of, and everything else falls into place. That involves skeletal muscle. That involves sensation on your skin, right? You know when someone's touching you, yes? Okay. So all of that is under the heading of somatic, which means everything that is involuntary, you are not consciously aware of, is going to be in a category of visceral, sensory, autonomic motor. Okay. Does that make sense? Visceral motor, involuntary, or not consciously aware of. Okay? Another way of looking at this. Uh-huh.
How do you tell if somatic from sensory or motor? Because both of them involve skeletal muscle.
Correct. So, somatic sensory is when something happens to tell the brain information. Remember, somatic sensory is coming into the CNS. Whereas somatic motor is efferent. Okay, is efferent. So it's a response. Okay? Uh-huh.
So going back to your question about the bladder, when it was, 2 or 4,
Uh-huh.
I guess I was confused when you asked because you said that your bladder is full,
Yes.
right? So, I mean, like, I was thinking that was involuntary because it's not like I have control over, well, I mean, I kind of do, basically, but, like, I didn't pick 2 because you didn't say that the brain knows your bladder is full, you just said the bladder is full, so that seems more like.
But that's the original source of information. The bladder is full, the bladder is a viscera. You're not consciously aware of it, really. The brain, I mean, yes, you know you gotta pee, but that information is sent to the brain when it's really full, right? So the brain is kind of monitoring your bladder status, and it gets information all the time, going this way, from the bladder to the brain. It's being fed information all the time. And then when the message gets, okay, I got it, now you're like 80% full, the brain is saying, it's time to pee. And that's when you start to look for a bathroom. that make sense? So the bladder being full, the bladder is a viscera, right? The bladder is an organ, internal organ, sending information to the brain. That make sense? Okay. Yeah.
Is that the same way it works like with the stomach when you feel hungry?
Yes, correct. Internal organ like your stomach, you can hear it growling, but it's already sending a message to the brain that, hey, it's empty. I need something in here. Right, so the stomach, empty, sending a message to the brain, and then the brain say, oh, it's time to eat, let's go find food, right? Okay, yeah. Okay? Make sense? All right, so you can read all this on your own, okay? We're gonna cover more details over this week and next week. Okay, let's go to nerve cells now. And we kind of did this already with a nerve cell. I want to find a picture. Here we go. Okay. Let me pull this down. Hey, talk to your neighbor.